everyone, welcome back to my YouTube channel. My name is Noy from Addis Ababa University. Today I am going to show you how you can solve this problem. Before starting this problem, if you are new to your educational tube and if you can't see the last 10 questions, I recommend you to see that question and come back here again. Now let's jump into this problem. This problem is calculating the distance between the two mass spheres that have the force of attraction based on the given condition. As you can see here, calculate the distance D. Calculate the distance D from the center of the Earth at which the particle experience equal attraction from the Earth and from the Moon. Here we can get Moon and here we can get the Earth, and here is the point. And these points have an equal attraction from the center of the Earth and from the center of the Moon. Then what is this distance D? And the particles restricted to the line through the center of the Earth and the Moon justify the two positions physically. Then we can use your dynamics book table to dynamics table and Appendix D, or you can, in order to know the mass of the Moon and the mass of the Earth, or we can use other reference in order to know the mass of the Moon and Earth. Simply calculate. First we will draw the free body diagram. This as you can see here we can get mass and here we can get Moon. Here RAM is the radius between Earth and Moon. We know this. It's all given. You can read it by using table or other methods. And here we calculate the distance between the center of the Earth to the particles, and we can ask to find the distance D. First, find the gravitational force. In order to solve this problem, first you find the gravitational force exerted on the particle by the Earth, which is force 1 is equals to gravitational constant times mass of Earth times mass of particle over d square, which is the distance between the center of the Earth and the center of the particle. And we'll find the force 2, which is the force of attraction between the Moon and the particles, which is gravitational constant times mass 1 times mass of Moon over d minus r square, which means RAM means the radius between the distance between the center of the Moon to the center of the Earth, which is already known, and d is also the required one. Then the two forces are equal, it's given, and we can equate them and cancel the like something. G by cancelled by G, and mass of particle also cancelled by mass of particle. Here we left mass of Earth over d square is equals to mass of Moon over d minus r square. And we will know about the mass of the Earth and mass of the Moon is given. Mass of the Earth is equals to 7.348 times 10 to the power of 20 kilogram, and mass of Moon is this. Then we can substitute and we simply calculate D. After substituting this, we can get the quadratic equation like this, and we can solve it. And finally we can use different method in order to solve this quadratic equation, and finally get the distance D from the center of the Earth to the particle that have equal attraction force between the Earth and particles and the Moons and the particle, which is 346 or 3.56 times 10 to the power of 6 or 3.4654 times 10 to the power of 6. We can convert it in different units, or simply we can calculate this distance D by using the equation this: gravitational constant times mass of over d square is equals to d minus r. Then simply simplify it and get this answer. Simply the answer is the same. Even though we can use a different step, we can guess your final answer is the same. This is all about question number 11. If you have any question, you can put it in a comment section. Unless next we will do question number 12. Until that, I enjoy the rest of your time. If you like this video, make sure to subscribe our YouTube channel and share it for your friend and donate your likes. Until next time, I enjoy the rest of your time again.